Okay, Muhammad, thank you for presenting to us today. Artificial neuron network is a very interesting subject. Please go ahead and introduce yourself.
Hi,
Muhammad.
this is Muhammad Al-Dushi, studying software engineering, and today I would like to talk about artificial intelligence, focusing on neural network. And I guess it's an interesting topic for everyone, because as you all know that artificial intelligence field is growing very fast and becoming more important in these days and next years. So all of us should have a look and read about this topic in order to get a small understanding about it. So moving on to our agenda here. Go ahead and
Okay. Sorry.
next.
Yeah.
Here our agenda, and we will start with the general introduction about artificial intelligence and how it's related with the machine learning and deep learning as well. And then we will move to our topic, which is neural network, and we will explain it in details, and we will see the difference between the artificial one and the biological one that we have in our brain as well. And then we will move next to the architecture and the models that we have. And then we have the probabilities, and we will show the small example in order to understand how the neural network work. At the same time, we have the biological neurons. We will see how it's work in our nervous system. And then we have the learning process. We have 3 types of learning process as well, which the supervised and supervised reinforcement learning process. And then we have some type of neural network. Well, I just wanted to mention about 2 most common types, which is the CNN and the RNN. But we have more different types, and these types are designed in different way. So after that, we will go to the practice part, and we will create a neural network, and we will see how it's how can we train the neural in order to solve a problem for us. At the end, I would like to show my project that I've been working in last semester, and it's about the stock marketing project prediction for the Yahoo company. Moving on to our introduction. Here we have the small introduction about the artificial intelligence, which comes at the beginning. It consists of two parts: machine learning and deep learning. So basically, artificial intelligence in simple way is a science that develops computer or machine to perform a task or a specific task, let's say, that requires typically and human intelligence, such as solving problems or making decisions and so on. We have so many problems, and then we will go to machine learning, which is the subset of the artificial intelligence. And machine learning is focusing more on algorithm and statistical model that enable computer to perform a task in a specific way. And this is happen when you when you feeding the model or the machine with the data, and the data start training from this model and learn, and to give us an accurate prediction based on this data we feed this model. And it's think you are training a computer to learn from the exam, like us, we are training from the experience. So while we are implementing the machine learning, we need to implement some deep learning, which is basically teaching the computer to be more smart, like our framework. And this is basically using an artificial intelligence and some hidden layer in the artificial neuron. Moving on to our topic, which is the neuron. Here we have the neuron, also known as a artificial neural network, which is the computational model or mathematical model that obviously inspired by the structure or the functional that we have in biological neuron in our brain. And this artificial neuron used in machine learning and the artificial neuron to solve a task such as a classification, regression, and so on. We have many tasks in real world. We can use the artificial one instead of human. to solve this problem. And we have the network, which is, as we said, we have a huge number of neural network connected together with something called weight. So weight is like in neural network is like processing the information inside the neural network and responsible for the connection and submitting the signals from neural to neural in order to predict or give us a solution for the problem. We already explained about the computational model, which is inspired by human, and we have here massively parallel, which is in our brain. Like we have a huge number of neurons that are working together at the same time to process an information in different places. So in our brain, like it's a complex and can perform many tasks at the same time. Compared with the computer, we just can do only one task and following the order to other tasks. Moving next to the other slide, here we have some stages that are showing us how the biological neural work in our nervous system. We have the stimulus, which is the changes or the external signal that we have in our environment, for example, touching something hot or cold. And we have the response, which is the cells that are responsible and acting like a sensor. So when you touch something, it tells you this is something hot. So this is how the response work in our nervous system and sending the signals to the neural network. So basically, neural network here we have it. It's responsible for the communications between our body, like for example, receiving the signals from the response that we take it from the external environment and send it to our brain in order to process and give us a reaction for that. And then moving to the effectors, which is responsible for the movement of our body, like for example, moving your legs or moving your hand from the object that you are touching. It's like basically just responsible for the movement. So responsible for the movement, it means like carrying out the signals from the response. So response is like creating a signals that are responsible for moving your hand from the object that you are touching. For example, you are touching something hot, so you need to move your hand. So this signal, responsive signal, send it back to the effectors in order to move your hand up. So this is basically a general information how the neural network, biological neural works in our nervous system inside our body. Moving next to our next slide, we have here some difference between the biological neuron and the artificial neuron that we have in the computer, and we can create it as well. In terms of processing elements, as we all know, like we have a huge number in our brain, that a huge number of the neural and many switches that call synapses, and this number around trillions, 100 trillions of connection, and these synapses working like processing the information and sending the signals from neural to other neural to produce a movement of our body or process a function or solve any problem. Compared with the computer, we have only like a few number, which is about 100 millions and 20 billions of switches that called transistor, and this transistor works as the synapses as well. They are responsible for the moving the signals from neuron to the other neuron by the connection between them. We have also the fault tolerance, which is basically as we are a human, like we usually make mistakes, but in computer you just like give the computer some structure and the computer will follow this structure unless you did something wrong with the structure or was something missing in the code, let's say. And then we have the style of the competitions, as we explained in the first slide. We said our brain is distributed, but in our computer is centralized because like our computer, like it's like a team of people can work together at the same time to process a different information or different tasks at the same time. It's like that's why our brain is more smarter than the computer. But in computer or the artificial neural, they're just like doing one task and moving to the other task. They just like following the specific order. Based on this order can work And then we have the processing speed. So our brain is a little bit slower than the computer. So can anyone like tell us like why the computer is faster than the our
Because
brain?
ChatGPT is like
Yeah, but
it
obviously
uses AI to
because of the huge number of the neurons and the connection between them, is then this is the effect, the speed of the brain.
it's programmed to
Yeah, because we have like a huge number of neurons in our brain, like trillions, 100 trillions, and these are connected together with the synapse and makes the brain is a little bit slow. And then like in terms of the intelligence and the conscience, which is like our brain is like super smart compared with the computer, where we can think and learn very fast and implement the task in accurate way. But computer, we just like give the computer some task, and based on these tasks, he will do it in faster way only, without thinking or any feeling. Just move on to the, here we have the biological neuron, which is consists of the most core parts here. We start with the dendrites, yeah, which is the branches that are connected with the cell body. And basically the dendrite is responsible for the receiving the signal from the neuron to the cell body. It's just like sending everything. So in cell body is basically is a central control of the neuron responsible for all the movement inside the neuron, and also like processing the signals that we receive it from the dendrites. After processing, we send it through the axon, which is the wire connecting between the cell body and to the other neuron. And this is basically like sending messages or delivering messages from the cell body to the other neuron in order to keep going to the. And then like we explained about the axons, we have also the synapses we explained before, which is the responsible for the connections and sending the signals from the cell body to the other neuron. It's like a bridge sending information from person to other person.
Can I ask you to turn and visit to us for the No, forget that. You're being present.
Okay,
We are your audience.
now we will move to the artificial neuron. So we have here the artificial neuron, which is has multi-layers. For example, we have the input layers, which is where we feed the neuron with the data in order to process. And these inputs, we have it here, it could be numbers or pixels of the images. Sometimes we process some or detect some images in order to see if, yeah, and then we connect this layer with the other layers with the width, which is responsible for the connection, and we can determine the width while we are doing the training process, because at the beginning we set the width here, and we give a value for this width like randomly. But when we trying to learn, when we try to start the training process in the neural, we need to change it in order to get an accurate result for this. And then we have like the bias here, which is the final step. After multiplying the input with the width, we apply the bias at the we add the bias as like a final step to make sure everything is working right. And then moving on with the activation function here, basically it's really important to add it in our neural, because it has some formula, and this formula is responsible for giving you the final result. Based on this formula, you can like decide if this result is correct or not. So it gives you a balance between 0 or 1. So we have here an example. We apply the first one here, and this activation function used in detecting an images. For example, we have an image that we want to detect if this image is like a cat or not cat. So we use this activation function here in order to see, like, if we get like the result near to 0, it means that it's not a cat in the picture. If it's near to y, it's near to number 1, it means that like it's a cat. And we have also the input layer, which is the final decision or the final result here.
the output.
Yeah.
Okay.
And we have this slide, learning process in neural network. Basically, we have like some learning type. So for example, we have the supervised learning process, which basically like having a teacher that guide you in learning process to process or work or learn. And what does that mean is like you having so this learning process uses the label data. So first we need to feed the neural with the data in order to learn from this data, and based on this data we can predict. For example, you are working in prediction price or weather prediction. Yeah, you need to feed first the neural with the data for the old data. So the neural start learning from this data and try to give you a price for the next month, let's say.
Earthquake, for example.
Yeah, it's just like guiding. But unlike the unsupervised learning, which is using the unlabeled data, where there's no any output or any guide, so the machine start learning by itself. So what does that mean? Trying to discover the pattern and trying to detect all the objects in the image. For example, if you are working in an image and you want to the computer to detect this vehicle, if it's a car or truck. So the machine learning in this process is trying to detect all the part of the vehicle and try to learn by itself. So once detectable and get familiar with the object, it will give you a result based on this. It's like learning by itself without any guidance. And we have the complex learning process, which is the reinforcement learning process, which is a computer learning tried by the different things. Like you are having a robot and you want from this robot to play video game, and without giving him the structure or any rules that to follow this game. So the only thing you give, like you give the robot a point when it does well and you minus the point when it does wrong. So by the time the robot will learn by the time we learn by trying different things. For example, after that time, like by the time it will give you a better decisions. Also, we use this in interactive with the environment. Let's say we use in self-driver. So while you are driving, the machine will interact with the environment, and based on the environment will give you a solution at that moment, whether to stop or continue driving. And moving on with the next slide, we have here the video, nice video that explains what's the neural network we can run.
I can run it.
Maybe we can share the link after the presentation.
Okay, no problem. We have here an example. Is this a koala or not? This example shows you how the neural network works. So we have these people that didn't hear about this animal and they didn't know about it. So what we will do is we want from these people to train and give us a decision if this is a koala or not. So we separate into two groups. So we have this group will detect it. Can you just like move on to the next slide? And we have here each person has take a part of the body and try to guess if it's a koala or not. For example, the first one is trying to guess if it's an ice koala or not. Based on that, we have here the weights, as we explained, which is the determining the connection between each neuron, and we have the scalar. If it's near to 0, it means that it's not koala. If it's near to 1, it means that he's sure. If it's a koala, he's sure it's a koala. And like, can you move on and show them the formula?
The next one?
Yeah.
Okay.
Here we train the people here and we get the result from them, and we have here the person, which is the hidden layer that works in deep learning. We have here the weights here and the I, which is the value of this person. We will multiply them together, and
It will give results.
after that, yeah, it's a formula. Can you just like one?
Prompt?
Yeah, now we get the result from each person here as you can 0 at 0 0 at 0.8, and we have the 0.9 and 0.6, the value that we get from the people, and the prediction was near to 1, which is it's equal, obviously, and we apply the formula and we get like 0.79, which is bigger than 0.5, and the result is equal. Unlike the next group, which is we give them a different picture, and we wanted from them to guess if it's equal or not, and so the result is less than 5, so 0.5, which means it's not equal. Moving on. So this is the structure of the artificial neural network, and this like showing you the first layer, which is the input, and the middle layer, which is the middle layer, which is responsible for the hidden layer, and then we have the output layer here. So the output layer, it will like apply the activation function by collecting the value in the hidden layers, and after that we can get the result at the end. So we have here but in the first person we have the head of the animal, and the other part of the body is responsible for the next one, and collect them together, and we can predict for the final result. Moving on to the other slide, we have here some types of, as we said, we have many types of artificial neural network, and these types are designed and architecture in different way. And each type like responsible for a specific task, let's say. And I just like wanted to mention about the most common type, which is the CNN standard for the convolutional neural network, which is processing and designed for detecting an image or videos. And how this like CNN work, basically by filtering the image from the first pixel to the other pixel, moving through all the picture and break it down into small layers. As you can see here, we have like multi-layers of the same type of the artificial neural in order to detect each pixels in details and multiply their weights to get the accurate result for that. So after that, we connect all the layers together, and then we apply the formula, for example, the sigmoid or any type of formula that are related with this problem. After that, we can like get the output result if it's there in the picture or not.